All right, we're starting on Module 5, Topic 1, Lesson 4. This is the last lesson in this topic, and then we're moving on to the very last topic, which is Module 5, Topic 2 on volume. So we're ending on scientific notation, primarily focusing on adding and subtracting numbers in scientific notation. So last time we worked on multiplying and dividing. Before we get to adding and subtracting, the process for that, we're going to talk about this context here, which looks at distance, average distance of each planet from the sun. So we can see like Mercury, it's this many kilometers, so 58 million. We're just going to convert each one of these to scientific notation. So the decimal is right here at the end of the number. We need this to be 1 to the right of the first non-zero number. So for this, it's just 1 to the right. It's going to be 1 to the right of this 5. So we're going to count 1, 2, 3, 4, 5, 6, 7. So the way we write this is we're going to write our mantissa, which is 5.8. It's pretty much everything except zeros. So we're not writing the zeros here. Times 10 to the, I believe we moved 7 to the left, so 7. Venus, this decimal's right here, but it's got to be 1 to the right of this 1. So we want to write 1, 2, 3, 4, 5, 6, 7, 8. We'll put this as 1.08. We don't typically write zeros unless they're between two non-zero numbers, so it's between 1 and 8, so we do include that 0. So since we moved 8 this way, it'll be times 10 to the 8th power. These are positive exponents because these numbers are bigger than 1. But I'm going to give you the answers for the other ones as well. So this will be 1.496 times 10 to the 8th power. Mars is 2.28 times 10 to the 8th power. We have Jupiter, 7.785 times 10 to the 8th power, a lot of 8s. And then we have some planets that are further away, so Saturn, this will be 1.43 times 10 to the 9th power. Uranus and Neptune, respectively, are 2.88 times 10 to the 9th. And the last one, 4.5 times 10 to the 9th. And if we went a little bit fast there, you're welcome to try to convert it from standard form to scientific notation to figure out, right, why are these numbers in scientific notation accurate. Okay. All right. So we're going to move on to the next page. So we're on 663. It says compare the distances from Mars to the sun and Venus to the sun. So A, use the standard form of the distances to determine on average how much further Mars is than Venus from the sun. So we're going to take this in standard form. So we need both those numbers. Let's take Mars and Venus. We have Venus right here, Mars right here. And I'm going to write this out. Let's say, so let's start with Mars since it's bigger. 228 million. And now let's take Venus, 108 million. All right. How much further is it away? Right, so we're comparing distances. So we're going to be subtracting to see how much more it is away from the sun. Right, so obviously when you subtract using the traditional algorithm, you subtract from right to left. So we're going to put 0 minus 0, 0. These will all be zeros here. I'll put commas for each 3. This will be a 0. 2 minus 0 is 2. 2 minus 1 is 1. All right, so we're going to say on average, Mars, I'm going to write it like this. Mars is 110 million miles farther from the sun. Okay, let's write this answer in scientific notation. So again, decimal, if we don't see it's at the end of the number. You want it 1 to the right of the first non-zero number. So we're going to say 1, 2, 3, 4, 5, 6, 7, 8. So this would be 1.2 times 10 to the 8th power. All right, and C says compare the characteristics for the distances from the sun to Mars and from the sun to Venus. Then look at the characteristics of your answer in part B. So the characteristic is the exponent for each one of those. So this is an 8, and this is an 8 as well. So what can we say about this? They're both 8s here, and the answer that we have, the characteristic is 8. So we're just going to say for this, they are the same. They are all the same. Okay, and then D, compare the mantisas from the distances, for the distance from the sun to Mars and from the sun to Venus. Then look at the mantissa of your answer. So the mantissa here of these numbers, we have 1.08 and 2.28. If you look at, well, we could put 2.28 minus 1.08. 1.08. If we find the difference of that, right, this is 0, this is 2, this is 1. And whenever we subtract decimals, you always want to line up the decimal point. So that's exactly the same as what we got over here. 1.2 is the same thing as 1.20. We're just going to say the same mantissa as part B, as listed in part B. And then 3, compare how to calculate the difference of two numbers written in scientific notation that have the same characteristic. Pretty much is to subtract two numbers written in scientific notation with the same characteristic. We just subtract the mantissa. Okay, so if we write this in scientific notation, we're talking about this right here. This is the mantissa. That's all we got to do. So we don't actually have to do this because this is 0 minus 0 business here. That's not useful at all. So what is useful are these front numbers. Okay. All right, let's go to number 4 on the next page. All right, so still looking at the distances of planets, it says compare the distances from Mars to the Sun and from Mercury to the Sun. Use the standard form to determine on average how much further it is away, and then we'll get to these other problems. So we have Mars to the Sun, Mercury to the Sun. So Mercury is here, and so Mars and Mercury. So let's write this in standard form. This is 58 million, and this is 228 million. Okay, so let's remember that. And as I said, I just forgot it. Okay, 228 million. And I believe it was 58 million. Okay. Right, I'm gonna have to squeeze this in here. We know that these are gonna be zeros. So the hundreds and the thousands place, this will be a 0 here. And then if you subtract 5 from 2, that doesn't work out. So subtract 5 from, think of it as 22. You can use your hands to count, but that is 17. So we would say that Mercury is 170 miles farther from the Sun. I'll just say farther. Oh, we should say Mercury is. All right. Okay, so now let's look at this next problem. So it says, so this is taking that problem. We wrote in standard form, but for B, it says Carlos and Tanya use scientific notation to evaluate it. So instead of using 228 million, they used in scientific notation. So 2.28 times 10 to the 8th power. And instead of 58 million, they used 5.8 times 10 to the 7th power. So we have to notice things that are similar and different in these two methods here. So we have Carlos and we have Tanya. So it looks like Carlos first rewrote 2.28 times 10 to the 8th as 22. So it looks like they moved the decimal point right here in between the 2 and the 8, so that they would get this, but also we have a different characteristic of 7. The reason for that is because we talked about how you have to have the same characteristic. We have the same characteristic right here. Oops. So when you have the same characteristic, then you can subtract the mantissa. So 22.8 minus 5.8, we're going to get is 17. Now notice how 17 is not in between 1 and 8, or sorry, 1 and 10. So we have to move that decimal point back again, and we have to add this 1 to the 7 to make it an 8 right here. Okay. All right, whereas Tanya did it slightly different, right? Keep in mind again, we have different characteristics, different exponents. So it says, oh, sorry, that was for the same problem. So Tanya rewrote this number, 5.8 times 10 to the 7th, as 0.58 times 10 to the 8th. So she moved the decimal point one to the left, and moving it to the left makes the exponent go up. So that's why instead of 7, it's an 8. Right, so maybe think about this. If you move the decimal to the left, the exponent, oops, we'll add the exponent. And if you move the decimal to the right, we subtract the exponent. Right, so over here, we moved it to the right here. So that's why we had to subtract 1 from this 8, and that's how we get this 7 right here. Okay. All right, anyways. So this problem right here then becomes this problem right over here. So we have the same characteristic, which is now an 8 instead of what the other student had, which was a 7. We're now going to subtract these two. And $2.28 minus 58 cents, that is $1.70, or 1.7. And this is in scientific notation because that number is in between 1 and 8. So what is different and similar? So each person like converted to the same characteristic. We'll just say got the same exponent. Right, in this case, characteristic means the exponent. Carlos converted the first term. Carlos converted the first term. Whereas Tanya, she converted the second. Okay, so two different routes to get to the same thing if you want the same exponent. And that's the only way that you can start subtracting or adding. So with this, you cannot subtract this because they do not have the same exponent. So just be careful with that. Must have the same exponent or characteristic. All right. So describe how to calculate the sum or difference of two numbers written in scientific notation with different characteristics. So you need to think about this as like when you add fractions, you need a common denominator. We need something also in common. So to add two numbers written in scientific notation with different characteristics, you need to rewrite one of the numbers to have the same characteristic. So that might lead to a choice overload, but just pick a number, say this is the exponent, this is the other exponent, I need this to be the other exponent. Think about whether you have to add or subtract to get that exponent, and that'll tell you how much to move the decimal point. Then after this, then you can add the mantissa and keep the exponent the same. We'll say, and keep the exponent, I'll just say characteristic again. Now, sometimes when you either add or subtract, you get a mantissa that's not in sine notation because it's not in between 1 and 8. So you might have to, there's like a third step maybe. You might have to rewrite so that it is in sine notation. So rewrite in, I'm just going to abbreviate here, scientific notation. Okay. So for number 6, it says calculate each sum or difference. We're going to do 2 of these as examples, and the other 2 will be UDOs, and I think we're just going to call it there. We're going to skip some of these other problems. All right, so let's start with the first one. We'll do the first and the second. Okay, so I like to think of this acronym here. So I call it LARS. This means if I want to add something, I have to move the decimal to the left and if I move a decimal to the right, I have to subtract that exponent. So just keep that in mind. Okay. Now we can see how we do not have the same characteristic. Okay. I'm going to pick one number. Typically I always pick the first one. It actually doesn't matter. I mean, we could pick the second one also. You know what? Let's pick the second one, I guess. I don't know. I need this 6 to become a 5. So in order to become a 5, I have to subtract 1 from it. So to subtract 1, right here, I have to move the decimal to the right. So since I said 1, I'm going to move this 1 to the right. So we have a new problem now. This first one still stays 3.7 times 10 to the 5th power. But this now becomes, instead of 2.1, it's 21 times 10. And I subtract 6 minus 1 as 5. We have the same characteristic now. Now I just focus on the mantissas. I'm going to add 21 with 3.7. I need to align with the decimals here. Right, you could think of the decimal there. You could put a 0 right here. This is 7. This is 4. Let's put the decimal. And this is a 2. So this will be 24.7 times 10. Same exponent. I don't do anything with it. I don't add the 5s. This is just a 5. Our answer. Okay, we're almost done. We have to look at our steps, though. We did add the mantissas. We have to rewrite in scientific notation. 24.7 is not in between $1 and $10. In order for me to do that, I need to move this 1 to the left. So 2.47. Since I moved it 1 to the left means I add that 1. I'm going to add that 1 to this 5. So it goes back to the 6th power. So this is $2.47 times 10 to the 6th power. All right, let's go to the next one. Okay. So it looks like I need to add. Okay. I'm gonna make this exponent, the 2, try to become a 4. So I need to add 2 to it in order for it to. So since I'm adding 2, I need to move that decimal point 2 to the left. So this will be 1, 2. So to rewrite this will be 2.5 times 10 to the 4th power minus, looks like this will be 0.031 times 10 to the 4th power as well. Okay, we have the same characteristic. Now we have to subtract these numbers. So we're going to line up the decimal. 2.5, we'll put 0.031. We'll subtract. Now, whenever we subtract, we have to borrow in this case. I cannot take away 1 from 0 and get a positive number. I can't take away 3 from 0 and get a positive number. So what I like to do here is, instead of taking it from this 0 here, I'm going to take it from the next 2 place values, which is 50. If I take away 1 from 50, this is a 49. And since I took 10 ones, 110, I'm going to make 10 ones here. This becomes 10 minus 1, which is 9. We now have 9 minus 3, which is 6. 4 minus 0, which is 4. Put the decimal. And 2 minus 0, which is 2. Okay. This is a number in between 1 and 10. So we write our final answer will be 2.469 times 10 to the 4th power. We don't have to rewrite since it's in between 1 and 10. So good. All right, I'll leave the next problem for you for B and D. Let's look at this. Do you want to go through any of these problems? These are mainly just contexts, but we've already practiced things like this for dividing. Yeah, we're gonna forego this. Okay, we're skipping talk to talk. On our assignment is on page 669. You're not doing all the problems, so just make note of this. You're doing number 1, all of number 1. On number 2, you're choosing 2. Number 3, you're doing A and B, and number 4, you're also choosing 2. So you're doing 2 of each on the back side. So right here, choose 2. For number 3, I'm choosing the 2 that you're doing, and for number 4, you have an option of choosing which ones you'd like to do. Let's say A through C. Ignore D for now, and that's pretty much it. So numbers 1 through 4, and some special directions for which problems you need to do. Okay. Anyways, let's get started on our assignment.